So we've done adding, subtracting, multiplying. Now we're going to talk about how to divide complex numbers. To divide complex numbers, we're going to multiply the numerator and the denominator by the complex conjugate of the denominator. A plus bi and a minus bi are complex conjugates because when we multiply them together, the imaginary part disappears. When I multiply complex conjugates together, my complex numbers become real. Okay. So our first example is 3i divided by 2 plus 4i. All right, so if my denominator is 2 plus 4i, what's the complex conjugate? 2 minus 4i. The only thing I change is the sign on the I term. Everything else stays exactly the same. Okay, so I'm going to multiply by the top and the bottom. Now when I distribute on the top, 3i times 2 is what? 6i. And 3i times negative 4i is negative 12i squared. What does I squared equal? I squared is negative 1, so that makes this 6i plus 12. Because negative 12 times negative 1 gives us positive 12. And then we are going to multiply out the bottom. So this is my numerator. I'm going to multiply out my denominator either using FOIL or vertical multiplication. It's up to you how you like to do that. I get 2 times 2 is 4. 2 times negative 4i, negative 8i. Then I get 4i times 2, positive 8i. And then I get 4i times negative 4i, negative 16i squared. And look at how my I terms cancel. Right? That's why we're multiplying by the complex conjugate, because just like we can't have a radical in the denominator, we can't have imaginary numbers in the denominator. So many rules. 4 and then negative 16 times the negative 1, that is I squared, becomes plus 16, which is 20. So far, I have 6i plus 12 over 20. Can I simplify that? Can I divide them all by the same number? I can divide them all by 2, right? So if I divide 6 by 2, I get 3i. 12 divided by 2 is 6. 20 divided by 2 is 10. If I'm putting it in a plus bi form, that's 6 plus 3i over 10, or 6/10 plus 3i over 10. I'm okay with you leaving it like this, but sometimes the answer key might switch it up, especially if it's in like multiple choice. And then this would be 3/5 plus 3i over 10, because you can reduce 6 over 10 some more. Okay, so this is a plus bi form, where it separates them. Okay. I mean, technically this is the correct form. That's standard form. I don't have an equal sign, right? So it's not an equation. So I can't multiply everything by 10 to make the variable go, the denominator go away, because I don't have the another side. So it doesn't eliminate anything. I'm just changing all the numbers. So we have 5 plus 3i divided by negative 1 minus I. So what's my complex conjugate of the denominator? Negative 1 plus I. The only thing I'm changing is the sign on the I term, okay? Negative 1 plus I. And then I have to distribute out, FOIL out the top and the bottom. So we'll do the top, 5 times negative 1, negative 5. 5 times I plus 5i. 3i times negative 1, negative 3i. And 3i times I, 3i squared. Which is, that's 3 times negative 1. So negative 3. Negative 5 plus negative 3, those are my like terms, right? Negative 8. And what do I get here? 5i minus 3i, positive 2i. Okay. We're kind of putting together everything we learned yesterday. The adding, the subtracting, the multiplying. That's my numerator. Any questions on how I got the numerator? I'm allowed to have I in the numerator. I'm not allowed to have it in the denominator. Okay, and so we'll multiply out the bottom. I'm going to rewrite it. Negative 1 minus I times negative 1 plus I. Okay, so this is just my denominator. Multiply my firsts. Negative 1 times negative 1 is positive 1. Negative 1 times I, negative I. Negative I times negative 1, positive I. Negative I times I, oops, negative I squared, right? So my negative I plus I cancels. I have 1 minus negative 1, so that becomes plus 1, which is 2. That goes in my denominator. Can I simplify? Negative 8 divided by 2 is negative 4. 2i divided by 2 is I. So negative 4 plus I. Questions? Mm-hmm. Then it's negative 1. Okay, yeah, I squared should always be replaced with negative 1. Okay, so now let's talk about graphing. So for following yesterday's notes, that would be part E, right? Graphing. Following today, making it new notes, it's part B. Okay, so to graph complex numbers, the x-axis becomes our real axis, and our y-axis becomes the imaginary. So this becomes 1i, 2i, 3i, 4i, and so on. And then negative 1i. Okay, I'll give you a second to finish drawing that coordinate plane. All right, so if I'm going to graph 5 minus 3i, which number is real? 5. So we go to 5 on the real axis, minus 3i. Am I going to go positive or negative? Negative how many? 3. And that's the point, 5, negative 3, basically. That's number 1. Yep.
So if I is the symbol for imaginary, is there like one symbol for real numbers?
That just doesn't have I. Mm-hmm. What about number 2? 2 is just 4i. Where would that go? 4 on the y-axis, or the imaginary axis. So that's point number 2. And number 3, negative 7 plus 2i. So negative 7 on the real and positive 2 on the imaginary. And that's point 3. See? Easiest graphing we've done all year, right? Yeah. Yes. You're going to have a worksheet I'm going to give you, and then you're just going to graph them all on this one little graph here. I forgot this had a backside. Okay. Okay, and then the last thing is powers of I. Remember, I is the square root of negative 1. We said I squared is negative 1. I cubed is negative I. I to the 4th was 1. We did this when we talked about I. The reason I to the 4th is 1 is because negative 1 times negative 1, I squared times I squared, is positive 1. So what do you think I to the 5th is? 1i, right? What about I to the 6th? If I go to the 5th, it's going to be 1 times I, so it's going to be I, right? The same as I to the 1st power? I to the 6th would be equal to negative 1. Because we can say, so I to the 5th, we can say that's I times I to the 4th, which is I times 1, right? We can say I to the 6th is I squared times I to the 4th, which is just I squared times 1, which is negative 1. As we continue the cycle, in groups of 4, it's repeating itself. I to the 7th is going to be negative I. I to the 8th is going to be the same as I to the 4th, 1. Right? So I to the 7th is I cubed times I to the 4th. So that's negative I. And I to the 4th is I to the 8th. I to the 4th times I to the 4th, which is 1 times 1, 1. So this repeats in a cycle of 4. Okay, so it repeats every 4 powers. So if I want to find I to the 49th power, I really don't want to write it out 49 times, do I? No? But can we find out how many groups of 4 is in 49? By dividing 49 by 4? 49 goes into 4 goes into 49 12 times, remainder 1, right? That means it goes through this cycle 12 times and it ends up at I to the 1st with 1 remainder. So I to the 49th equals I. No, 48 times 4 times 12 is 48. What's just happened? Let's do another example of the powers of I. I to the 75th power. Okay. All we have to do is divide by 4. So 4 goes into 75 once. 4 goes into 35 8 times. And I get a remainder 3. The only thing that matters here is my remainder. If my remainder is 3, that means it's equivalent to I cubed, which is equal to negative I. Okay? If I get a remainder of 0, if I do I to the 80th, 4 goes into 80 20 times, remainder 0. Remainder 0 means it's equivalent to I to the 4th. Remainder 0. Remainder 1. Sorry, remainder 3. Remainder 2. Remainder 1. And it's just I, negative 1, negative I, or 1 are your answers. So this is equal to 1 because the remainder is 0. That means it finishes a pattern of 4, exactly on 4. Okay.